Hi everyone! Welcome back to integralcalc.com. Today we're going to be talking about how to find the normal line to the graph y equals 2x squared plus 3x minus 5 at the point 2, 9. So just to talk about the normal line briefly, we've got a graph and I've gone ahead and graphed it here. The purple graph is the graph of the function y, so I'm just going to go ahead and label it y. And then I've gone ahead and indicated the point 2, 9, which is right here where all three of these intersect. The orange dotted line is the tangent line to the graph at that point. So that's the tangent line. The normal line, when we talk about the normal line of a graph, the normal line is the line that's perpendicular to the tangent line at that point. So this is the normal line graphed, so we can just kind of get a visual of what it looks like. Notice that it's perpendicular, it's at a 90-degree angle to the tangent line, and what we're interested in doing is finding the equation of this normal line. So we know that the normal line and the tangent line and the graph all intersect one another at the point 2, 9. So we need to use these formulas here that we've been given, f of x and m of x, to first find the equation of the tangent line, and then once we found the tangent line, to go ahead and find the equation of the normal line. So if you already know how to use derivatives and you can take the derivative of y, the function y, then it's probably easier to do it that way. If you don't know how to use derivatives yet, we can use this formula for f of x to find the slope of the tangent line. So what we're going to do is realize that our function y equals this function here is in the same form as this formula here, f of x. So notice that we've got 2 here as a coefficient on the x squared term. Well, that's going to be the same as p right here. And then if we pick another color, we have 3 as a coefficient on the x term, the first degree x term. That's the same as this q here, so q is going to be equal to 3. And then finally we've got negative 5 right here, which is the same as r. So we've got our equation in the exact same form as this f of x formula here. So knowing p, q, and r, we want to plug those in to this m of x equation to get the slope of the tangent line. So that's how we're going to do it. So m of x for us is going to be equal to 2px plus q. That's the formula. So we need 2 times p, which we already know is 2. So 2 times 2 times x, we just go ahead and leave that. And then we add q to it. And we already know that q is 3, so we go ahead and say plus 3. And if we simplify this, obviously we'll get 4x plus 3. So this is the slope of the tangent line. We just need to figure out what the slope of the tangent line is at the point 2, 9. So, right, because we've been given this point, 2, 9. So we go ahead and plug the point 2, 9 into our m of x function. And basically that's just going to entail plugging in 2 here, plugging in 2 for x. So we'll get 4 times 2 plus 3 plus 3. And when we simplify that, we'll get 11. So 11 is the slope of our tangent line. That's how we find it. Now we can either use point slope form or slope intercept form to find the equation of the tangent line. Since we already have a point, 2, 9, and we have the slope, 11, I'm going to go ahead and use point slope form because it'll be easiest. So remember that point slope form is y minus y sub 0 equals m times the quantity x minus x sub 0. So basically we say y minus the y coordinate, which in our case is 9, equals the slope, 11, times x minus x sub 0, which is the x coordinate from our point 2. So this is the equation of the tangent line in point slope form. If we want to simplify and solve for y to get the slope intercept form, we can do that as well. We get y minus 9 equals 11x minus 22, and then we would add 9 to both sides and get y equals 11x minus 13. So this would be the slope intercept form, or sorry, this is the point-slope form. This is the slope-intercept form for the equation of the tangent line. So I'm just going to go ahead, since tangent line is orange in our graph here, I'm going to go ahead and indicate that these are equations of the tangent line in orange. So now that we've found that, we can go ahead and easily find the equation of the normal line. So we're going to start by finding the slope of the normal line. The slope of the normal line is going to be the negative reciprocal of the slope of the tangent line. Because the two are perpendicular, their slopes are negative reciprocals of one another. And what that means is that we can take the slope here, 11, and we make it a negative, so negative 11, and then we flip it upside down to get the reciprocal. So instead of positive 11, we get negative 1 over 11. So the slope of the normal line is going to be negative 1/11. So knowing that, and knowing that the normal line is also intersecting this point P, right, 2, 9, we can go ahead and write the equation of the normal line in point-slope form. So again, y minus 9 equals negative 1/11 times x minus 2. So there's the equation of the normal line in point-slope form. If we want to write it in slope-intercept form, again, we can easily convert. We say equals negative 1/11 x plus 2/11. And then if we add 9 to both sides, let's call this 99/11. So if we add 99/11 to both sides, we'll get y equals negative 1 over 11x, and then adding 99, we would get plus 101 over 11. So let's just indicate in blue, these are both just two different ways of writing the equation of the normal line. The first one, remember, is point-slope form. The second one is slope-intercept form. But either way, those are equations for the normal line. So remember, you can either use these formulas up here for f of x and m of x and solve for the slope of the tangent line, or you can use the derivative, whichever you're most comfortable with. So solve for the slope of the tangent line, go ahead and write the equation of the tangent line, and then find the negative reciprocal of the slope to get the slope of the normal line. Plug in your point and go ahead and write the equation for the normal line. So that's it. I hope this video helped you guys, and I will see you in the next one. Bye!